Okay. The idea is that, looking at the game, it's a lot like soccer. Who wins in soccer? The team that controls the ball. So we're thinking more midfield, because the more of them start in the middle. When they're returned after scoring, they return to the middle. So we're thinking something like this. It's going to be low, less, so they can go through the tunnel if it needs to. The front of it will have a V connected to some sort of piston that will be able to hit the ball. Looking at the video, we saw Dean came and do that. Put it up and over the ramp, fine. Up and over the bump, really easy, really easy. And he also used that, yes. He also used that same force to score.
So this design is assuming that it takes the same amount of force to get over the bump from midfield to our goal area as it does to score.
So yeah. it can score, it can do that. To drive it, you'd have two really high friction wheels in the front using skid steer. The one in the back could be a swivel wheel, could be a low friction wheel, could be an omni wheel. Something like that, so that the front steering and the back's just sliding by itself. Yeah, there for stability. It would be a pentagon, that way we can put the pieces on every single side. We can put our number on all four sides like we need to. They'd have an air tank to run a piston for the kicker, the V. At the end, to pull us up onto the tower, you have a. Okay,
No,
what's it called for it?
I don't have one.
What's it called for
Carabiner. Oh yes, I do have one. You'd have an arm connected to a carabiner. It'd be a telescoping arm that would lay down. It would rotate up, telescope, and then you drive up to the bar, hit it. You're hanging on that bar. You use a winch connected to a cable. Wind yourself up to the bar. And you'd have the winch hooked up in the back, and that way you could have a bar in the front so that other robots could hook on and stuff like that. Did I miss anything?
Yeah, because when the robot pulls itself up on the bar, it pulls its ass up, and so the front of the robot is facing downward. So that's why
that's the front, that's the back.
That's why there'd be a bar on the front, so the other robots can hook up on it themselves to get up.
Any questions?
Would this robot be able to go over the bump?
No, we designed it so that it can go through the tunnels.
The main purpose would be to get our balls onto our side, so that way the other team wouldn't be able to.
That way our allies can put it into our goals.
And we were looking at it and we saw that if we have enough traction, we'll be able to push through any robot that tries to block us.
And we also figured that
because you just have two wheels.
And what?
Because you just have 3 wheels.
We have two wheels
drive wheels
running off of 4 sims.
Yeah. Run it through.
That's like a lot.
That's a lot.
And so we'll have the traction power to push through. And even if we don't, any robot that they have blocking that gate is a robot that isn't scoring.
The rest of our ideas kind of ran over around the idea of the amazing flip bot. Basically, our robot can go over the bump and flip itself over and keep on driving.
So you can use those
So it's like, hey, we flipped ourselves over.
Yeah,
just kidding.
Kind of like this. It would be like
wheels bigger than the frame.
We have to. Yeah. We have a couple different ways, so we're gonna go through.
No, I just gotta mention there's a rule. We're unsure. The bumper zone says the rule. The rule says that the bumper zone has to be at least 10 inches off of the ground.
10
to 16 is the bumper zone. But we just have to check to make sure that that's only at starting position and not when it's flipped over. Because what would change about our robot is if we did a flipping bot, then like this one where there's 10 inches on the ground and then it's like 4 inches above on the other side, it'll still be low enough that it can go under the tunnel as well as go over the bump. But if it's 10 inches either not only at starting point but for the duration of the game, then we wouldn't be able to go under the tunnel because there just wouldn't be enough
possible space.
and too high.
We have checked with actually did the checking with the
We have the 2010 Q&A is not up yet. But we are signed. We had to create a new login for the Q&A, but once it's up, we can go on and ask them, ask the clarification on the rules about normal configuration and if it applies during the entire match, and about the bumper zone. But that's not up yet. And so once that's up, we can get clarification on that.
But as it is right now, it looks like we'd be allowed to.
It depends on who's looking at it.
our next idea to do with that is just instead no longer have it be able to go under the platform, but make it so there's 10 inches of space on either side, and use two separate
Sets of wheels.
separate wheels. So
they're, like,
it's
stacked.
smaller wheel. So the wheels on one side, you flip it over, and it's another set of wheels
Here.
on that side. So it's like this is the top, this is the bottom. So you flip it over, and I have a different set of wheels driving the robot forward. But still, no matter which side you're on, you're still driving the robot around.
And
I am looking at directly at you for a reason.
so for driving upside down, you're gonna have the wheels chained and two vertical wheels chained, I assume, or
That was our original idea.
okay. You also
Yeah.
use one really big wheel.
Devin?
Could you, like, with that design, could your robot stand vertically?
No, but we very much doubt our robot would stay in a vertical position.
The other idea we had was instead you have it a little bit higher up, but then you put your three sets of wheels with shocks. The front shock being, instead of being vertical, being angled, so it only comes into effect when you're coming down off the hump. It pushes in to take the force, so you don't bounce and roll. With the whole strategy of don't worry about flipping yourself back over, just don't fall over. And the center set of wheels just move up and down for coming over the hump to keep you from getting like beached like a whale.
Analogy today. And we had also hoped that we'd be able to design the robot so that it would also be able to go underneath the tunnel as well as go over the tunnel, so that way if the tunnels are being occupied and are busy, we can go over the hump, and if the hump's taking too much time, well, then we can go under the tunnel, so we'd have flexibility as to where how to get moving back and forth when we needed to.
During the game, these would be flat against the robot. They would partially fold up, and we'd have this brace here, just try to control some more of the weight, and it would extend about, I don't know, halfway, probably a little less, and then telescope up, and then again with the winch and the kit.
The other thing was that
Blatantly stole from us.
other thing, there are going to be two of them. It's going to make sort of like the forklift of 08 maybe? Or 9?
Oh, no.
Or 9? Sort of like that forklift, you have two of them with the two carabiners.
No, it was not 08.
Whatever year. Rotate AD base year. So you're going to have two carabiners, so when you hook on, you don't swing around.
Too much.
Too much, yeah. And the other thing was that we're going to have the arm come forward, instead of 90, come forward, say like 100 degrees. If you only come forward 90, you won't be able to clip onto the wall, onto the pole. You'll come up flush with it, and then you'll be like half an inch short and just be like trapped.
Because once it's hanging, it's going to right itself 90 degrees anyways. If it's hanging.
Yeah.
Is it kind of a little scared that our other group seem to have comprehensive ideas that can actually work together?
If you guys think about what each team sat up here and said, you guys had some very basic things that you all agreed upon. I think if you take a few minutes and focus on those for a minute and say, okay, we agreed on this, we agreed on this, we agreed on this, we agreed on this. These are the things we disagreed on. Let's talk about each one of those things we disagreed on and agree on. And here's why I say that. Whether the scoring is based on 0 or whatever, you still have to build a robot that's going to be able to whatever, whether you want it to go through the tunnel or whether you want it to be able to go over. It has to do those things. It has to be able to reach up and get the bar. If you focus on the things that you want it to do, you're going to be making progress, right? And then talk about the things that you disagreed upon, and then figure out which way you want to go, come up with a solution to those, and that's what you go with. That's what I think you should take a look at.
So today we basically went over the preliminary design of the robot. Kind of decided on a punching mechanism using either pneumatics or some sort of spring-driven gadget. We decided we're going to use a telescoping arm with a winch. And we've decided the basic height of the robot, we want it to be less than 18 inches so that we can make clearance and go underneath the tower thing. I think today went okay. I mean, it was a little bit disorganized, but I think we got what we needed to get done. So.